So this is Unit 8, Chemical Reactions. We are starting at the top of page 3. Before I actually start this, we are going to use one chemical reaction to describe a lot of things in this unit. It's a good example for a lot of the things that we're going to do. It's this one that I already have written in. It's known as the Haber process. Here is my expectations in the beginning. I expect you to know what the Haber process is. So if on a test, let's say, on a test I say something about in the Haber process something, you should know the reactants and the products for the Haber process. So as we go through this, pay attention, make sure you understand it. It's not that complex, but if you don't put an effort to remember it, then on whatever day it comes up, you probably won't feel prepared. So the Haber process is something I expect you to commit to memory. So we're describing chemical reactions. Chemical reactions can be described in several ways. It could be a sentence, a word equation, a skeleton equation, or a balanced chemical equation. These are all possibilities. They all have their pluses and minuses. So we're using the Haber process as our example. It's an industrial process used to produce ammonia. Ammonia is an important component of fertilizer, some cleaning products like window cleaners. Ammonia is the common name for NH3. When we're talking about molecules, we can use common names, like H2O is water, NH3 is ammonia. When in doubt, use the chemical naming systems that you've learned in this class. So here's a sentence to describe the chemical reaction of the Haber process. Nitrogen gas reacts with hydrogen gas to produce ammonia gas. It provides a lot of information about the chemical reaction. For instance, nitrogen reacts with hydrogen. Those are my two reactants. Remember, reactants react. Nitrogen gas reacts with hydrogen gas. It also tells me the products. To produce ammonia gas. We are producing ammonia. So this sentence provides a lot of information about the chemical reaction. But using a sentence to describe this chemical reaction, it's got some drawbacks, has some disadvantages. First off, probably the biggest complaint, sentences require more space and more writing relative to other options. So I have this typed in this year. In previous years, it was a blank, and it spanned the entire page, and people were still running out of room. A lot of space, a lot of time. The sentence gives us a basic understanding of the reaction, but it also doesn't tell us everything. There are still things that we would like to know that we don't. It doesn't tell us about the chemical formulas. That would be helpful, especially if we're talking about converting a mass of something to moles. Remember, we always go to moles. It also doesn't tell us about the quantities. A chemical reaction is really a recipe. And like any recipe, the reactants have to be added in the correct quantities. If you're going to make cookies, you're not going to put in 10 cups of sugar if the recipe only calls for one. You're going to have very burnt cookies. Or if the recipe calls for a half tablespoon of salt, a half teaspoon of salt. You're not going to put in a whole tablespoon. That's 6 times too much. It's going to not taste right. We have to have chemicals being added in the correct quantities. And that's going to be a big portion of this unit as we go along. So I'm going to give us another sentence that we'll use as we go along in this unit. Hydrogen peroxide solution reacts to produce water vapor and oxygen gas. So here's my sentence. Hydrogen peroxide solution reacts to produce water vapor and oxygen gas. First off, reactants. There's only one. Hydrogen peroxide solution reacts. Products. It produces water vapor and oxygen gas. So we have one reactant and 2 products. This is a specific type of chemical reaction. In the future, you'll be able to identify what type it is just based on the information we have. As a side note, water vapor and oxygen gas. Water vapor is really steam or any type of water that's a gas. So why is it called vapor if it's a gas? Oxygen is a gas, and it's called a gas. Water is a gas, and it's called a vapor. And really it has to do with what is its state of matter normally at room temperature. So water is generally a liquid at room temperature, and so if it's a gas at room temperature, it's considered a vapor. Short version. So bottom half. To understand the different types of chemical equations, we need to define a few symbols. I already have them written in here just to keep things moving a little quicker. Feel free to pause it and write them down. So the first one we have is a plus sign. This separates reactants from other reactants. For instance, ammonia and hydrogen in the Haber process. We separate those 2 reactants with a plus sign. Or it could separate products from products. The hydrogen peroxide example, it would be the products are water plus oxygen. Next one we have is this arrow. It separates reactants from products. Now in this class, it typically moves left to right. This tells us the direction of the reaction. We have reactants, they're over here, they are going to be products. The next 4 tell us about the state of matter. Parentheses G, it's a gas. Parentheses, that's a lowercase l, liquid. Parentheses S, solid. Parentheses AQ, the substance is dissolved in water. This is the specific term for it. I've heard 3 different ways to say this word. All of them seem to be acceptable. I call it aqueous. I've also heard aqueous and aqueous. So any one of the three of those are probably going to be okay when you say it. The next one is a coefficient. I have it written off to the side because this is not the symbol itself. The symbol is a number between 1 and 9. I guess it could go higher. Between 1 and 100 maybe. It's a number that indicates the relative quantity of a substance, and it's written in front of the chemical formula. The last one, this little triangle, is actually the Greek letter delta. It indicates that the reaction requires heat. And this is where it generally shows up. We have the arrow separating reactants from products. The delta on top of it indicates that we had to heat this up for the reaction to start.